So in this video today, we're going to go over adding and subtracting rational numbers. So by the end of today, you're going to be able to say that you can add and subtract rational expressions. So when we're adding and subtracting rational expressions, it's similar to adding and subtracting fractions. So they must have a common denominator. Then you're going to just add and subtract the numerator. So here you notice that we have a common denominator. So all we have to do is add, sorry about that. All we have to do is add the numerator. So we're going to do 2 plus 7 over 5. So that is going to be 9 over 5. Now over here with this other one, we got to get a common denominator. So what we want to think about is what is the smallest number that both 12 and 8 go into? Well, if I start thinking about that, I think that that's going to be 24. So to do that, we've got 11 over 12 minus 3 over 8. So what do we have to multiply the 11 and 12 by to get 24? 2 over 2, right? And then over here, sorry, that's supposed to be multiplication. Over here, what do we have to multiply the 8 by to get 24? 3 over 3. Now remember, we're multiplying numerator and denominator by the same number. We're not changing the expression, okay? So here we're going to get 2 times 11, that's 22 over 24. And then 3 times 3, that's 9 over 24. So you should see that 22 minus 9 is 13. So the answer here is 13 over 24. So when we're talking about least common multiples of polynomials, that's what we call a common denominator. So we're just going to say this is equal to a common denominator. Sorry, y'all, my handwriting's not that great today. So to find the least common multiple, or the common denominator, we're going to factor each polynomial completely. So like, for example, in this one we have here, it's x to the third plus 6x squared plus 9x. We have an x in all of them. We're going to factor that out first. When we do that, we get x squared plus 6x plus 9. Now if we take square root of x squared and we take square root of the 9, we're going to get x and 3. And if we do x times 3 times 2, we get this 6x right here. See that? So we know that that's going to be x plus 3 squared. So then you're going to list the different factors. Now, if the polynomials have common factors, you're going to use the highest power of each common factor to figure out what the least common multiple is, okay? So this is what we're going to talk about with this first one, okay? So when we do this, this is the way I like to do it. I'm going to give you the multiples of 4, which are, actually, the multiples of 4 are 2 and 2, and then we got x squared, and we got y to the third. Now we're looking for the biggest x and the biggest y. So for the 6, we've got 3 times 2, and then we got x to the fourth and y to the fifth. Again, we're looking for the biggest numbers, okay? So we got to find what numbers, what coefficients do we have in the top one. So we have a 2 and a 2. Now we have a 2 here and a 2 here, so I don't have to write them twice. I only have to write them once, okay? Then we just have a 3, right? Then our highest exponent is going to be the fourth and y to the fifth. So 2 times 2 is 4 times 3 is 12. So this is going to be 12, x to the fourth, y to the fifth. Now this next one, to find the least common multiple, we're going to have to factor each of these, okay? So when we factor our x, we got x here, right? And we'll have the same thing over here because we have an x squared. So now we're asking ourselves, what are the two factors of, so what is negative 3x squared? So what are the two factors of negative 3 that when added together give you a negative 2? So that would be minus 3 and plus 1, right? Then over here on the right, we're doing negative 6x squared, right? So what are the factors of negative 6 that when added together that give me a negative 1? So our factors of 6 are 1 and 6 and 2 and 3, right? So we know it's going to be 2 and 3. just one of them has to be positive, one has to be negative. Well, this one will be positive and this will be negative because that's what gives me that -1. So it's -1x, right? Okay, so now this is what I like to do. I like to take the one that's repeated and I write it first. So that is going to go first. Then we're going to write everything that's not repeated. Okay, so we're going to write this and this. So we're going to have x plus 1 and x plus 2. So if we had these two equations as our denominator, then our common denominator would be this right here. Okay? All right, so let's do the same thing with this one. Go ahead and do this. Pause the video and come back to me when you're done. All right, so I'm going to do this. That's going to be -42x squared. If you're common, we have a leading coefficient. We put the 2x and the 2x, right? Then we're talking about what are the factors of -42 that when added together give you a -11. So we got 1 in 42, 2 in 21, 3 goes in there 14 times. Oh, yeah, so it would be -14 plus 3, okay? Remember, there's a GCF over here, so we got to factor that out. So this is going to be x minus 7, and this one's going to be 2x plus 3, okay? So, I'm going to do the same thing over here again. This is going to be minus 105x squared. Put 3x here, 3x here. Now we're trying to find the factors of -105x squared that give me, excuse me, a -26. So if I were to divide, I would do 5 first, divide 105 by 5. When I did that, I got 5 and 21, okay? So obviously the 21 is going to have to be negative and this is going to have to be positive because that's a -16. So, again, this can be divided by 3, so this is going to be 3x plus 5 and x minus 7. So what is our repeated factor? It's right there. So we're going to write that one first. Then we're going to do our 2x plus 3 and our 3x plus 5. So once again, if I was looking for a common denominator and these two equations were in the denominator of two different rational expressions, then this would be my common denominator. Okay, so now we're going to actually add some rational expressions. So this one already has a common denominator, so we're going to put the x plus 4 on the bottom, and then all we have to do is add what's on top. So we got an x minus 3 plus x minus 2. So that's going to be x plus x, which is 2x, -3 minus 2, which is -5, and that's going to be over x plus 4. Now, it also asks us, identify any x values for which the expression is undefined. Well, in this case, we're going to set the x plus 4 equal to 0, so x cannot equal -4. So there's our answers. So for the next one, we're going to have to factor the denominator of this right here. So that's going to be -4x squared. So I'm going to do x minus 3 over, we got an x and an x. So what are the factors of -4 that when added together give you +3? I would say that's +4 minus 1, okay? Then we have this plus 2x over x plus 4, right? Yeah, I can't write today, y'all. Sorry. So notice we've got the x plus 4 here and the x plus 4. What we don't have is the x minus 1. So I'm going to do x minus 1 here and the x minus 1 here because we've got to give them a common denominator. So when I do that, I end up with x minus 3 over here on the left, and then I get, and if I multiply that, over on the right, I'm going to get plus 2x squared minus 2x. That's all going to be over. Now, what I did was I put it all over the same thing because by now we have the same thing, right? So we can say x plus 4, x minus 1. Okay? So now we're just going to combine like terms on the top. So that's going to give us, so we've got an x and an x and x there. So we can combine those. We've got our 2x squared, which there is not another x squared. So then if we do x minus 2x, it's going to be minus x. And then we've got a minus 3. That's over x plus 4, x minus 1. So now we need to see, can we factor what is in the numerator here? And so if we multiply this times this, we're going to get negative 6x squared. And if we, I'm going to do it over here on the left, y'all. So I'm going to go 2x and 2x. So negative 6, so that would be minus 3 plus 2, right? Okay, now that can be simplified. So the factors on the top are going to be 2x minus 3 over x plus 1, right? Okay, so let's see if we can simplify this. So we have 2x minus 3 over x plus 1. That's all over x plus 4 over x minus 1. I don't see any common factors here, y'all. So as a result of that, that means that all we're going to do now is to simplify this problem. To do that, we are just simply going to multiply back. So I'm going to put this term right here back again because I couldn't cancel anything out and I already had it done. So 2x squared minus x minus 3. Now I'm just going to take this other term right here and I'm going to multiply it out. So x times x is x squared. Negative 1 plus 4, so that's going to be 3x. I'm using FOIL here, y'all. Or you could use the box method. Minus 4. So that's our answer right there. Now recall again, when we're talking about what we need to find, this down here is what we're going to use to determine what are the excluded values, or what values cannot be in the denominator. So we're going to do x plus 4 equals 0. So x cannot equal negative 4, and x minus 1 equals 0. So x cannot equal 1. So those are our excluded values right there, guys. So this is our last example, and then you guys are going to do some on your own. So let's go ahead and write this again. 2x squared minus 30. Let's go ahead and factor this denominator. X plus 3, x minus 3. So this time we're subtracting. We have the x plus 5 on top up here. I'm going to put it parentheses. We have the x plus 3. What do we have to add here to make it look like what's on the left? Don't we have to do x minus 3 over x minus 3? Okay, so now we're going to simplify this. So we get 2x squared minus 30 over x plus 3, x minus 3. Minus, let's go ahead and multiply this out again. So we can use FOIL or we can use the box method, whichever you're most comfortable with. So that's going to be x squared, negative 3 plus 5, so that's going to be plus 2x, and that's going to be minus 15. That's all over x plus 3, x minus 3. So now we can simplify, right? So we're going to combine like terms on the top. So I've got these like terms, right? And then I've got these like terms. But, whoa, wait a minute. Before I do that, we're subtracting this whole thing. Y'all notice that? So I'm going to make this a minus, and that one a plus before I combine them. So I now have 2x squared minus x squared, or no, yeah, minus x squared. So that's going to give me x squared. I've got a negative 2x. I don't have a 2x on, I don't have an x on the left, and then I've got the negative 30 and then positive 15, so that's going to be minus 15. And that's all going to be over still our x plus 3 and our x minus 3. So what do y'all think our next step will be? Yep, we're going to factor what's in the numerator. So we need to figure out what are the factors of negative 15 that would added together give me a negative 2, so that would be minus 5 and plus 3. We're putting that over our x plus 3 and our x minus 3. Hopefully right now you can see what cancels out. So we're left with x minus 5 over x minus 3. And our excluded values would come from here. So x plus 3 does not equal 0, so x cannot equal negative 3. X minus 3, so x cannot equal positive 3. A little slow. I don't know what's going on, but it's okay. There's our answers. Okay? So I'd like you guys to do 2, 3, and 4, and then come back to me after each one and check them with me, okay? So first of all, we've got 2x squared plus 64. We're going to go ahead and factor this. This is going to be x plus 8 and x minus 8 minus x minus 4 over x plus 8. Hopefully you can see that we got to multiply the top and the bottom by x minus 8, right? So we're going to do x minus 8 here, x minus 8 here. Now we should have a common denominator. So we're going to go ahead and simplify this. 2x squared plus 64 over x plus 8, x minus 8, minus x squared. Negative 8 minus 4 would be minus 12x plus 32, because negative 4 times negative 8 is positive 32, and we still have x plus 8, x minus 8 here. Now let's go ahead and combine our like terms on top. So hopefully you can see we've got a 2x squared and a, oh wait, actually before we do that, let's go ahead and change these signs. That's going to be a minus, this is going to be a plus, this is going to be a minus, okay? And then we've got this positive 64 minus the 32 right there. Hopefully you see that. So now we're going to go 2x squared minus x squared. That's going to be x squared. And then we've got plus 12x. And we subtract 32 from 64, so that's going to give us a plus 32. And we still have our x plus 8 and our x minus 8 down here. Going to factor what's in the numerator. So that's going to give me x and x. What are the factors of 32 that when added together give you a 12? That's going to be plus 8 plus 4. We've got this x plus 8 here, this x minus 8 there. Hopefully you can see what cancels out. So we're left with this. That's our answer. Now remember, we still got to tell our excluded values, so we're going to do x plus 8 equals 0, so x cannot equal negative 8. X minus 8 equals 0, so x cannot equal 8. Those are our excluded values, or the expression that identify the x values when the expression's undefined, right? Okay? All right, so this time we're going to factor this one, and that gives me a 9x squared, right? So we've got x. So what are the factors of 9 that would add them together give you a 6 plus 3 and plus 3, right? Okay, so over here we have an x and x plus 3, right? Plus 2x plus 6 over x plus 3 and x plus 3. So what do we have to do on the left, y'all, to give it a common denominator? We have to multiply both the top and the bottom by x plus 3. So that's going to give us x squared plus 3x plus 2x plus 6 over our common denominator, right? Which is going to be x plus 3, x plus 3. Okay? So again, we're going to combine our like terms right there. So this is going to be x squared plus 5x plus 6 over x plus 3, x plus 3. We need to factor what's in the numerator up here. So when we factor that, what are the two factors of 6 that when added together give you 5? That would be plus 3 and plus 2, right? Still over x plus 3, x plus 2. Sorry, x plus 3, x plus 3. That was my bad, y'all. Come on, eraser. So hopefully you can see again, these cancel out. So we're left with x plus 2 over x plus 3. And once again, this time we only have the x plus 3 twice. So x plus 3 equals 0. So x cannot equal negative 3. So this is perhaps the most difficult problem, so let's just talk it through again. So this time we have different denominators, and I can't factor them. So I'm going to go 3x minus 2 over 2x plus 5 minus 2 over 5x minus 2. So what I'm going to do is I'm going to take this denominator right here, and I'm going to put it on the right, and I'm going to take the 5x minus 2 and put it on the left. So I'm going to do 5x minus 2, multiply that on top up here, over 5x minus 2. Oops. I don't know how that happened, y'all. And then this one over here, I'm going to do the 2x plus 5. So 2x plus 5 over 2x plus 5. So I'm going to go ahead and multiply this out and see if we can get anything to cancel out or simplify. So that's going to be 15x squared. 5 times negative 2, that's negative 10 minus 6 would be minus 16x. And then negative 2 times negative 2 is plus 4, right? Then over here, we're going to subtract 2 times 2x, which would be 4x. And 2 times 5 would be plus 10. And all of this is going to be over 5x minus 2, 2x plus 5. All right, so now we got to remember we're subtracting this whole term, so we got to make sure this is the most common area, y'all. That's going to be a minus, that's going to be a minus, okay? So when we simplify this, we don't have another x squared, but we do have these two that are like terms, and we have these two that are like terms, right? So we're going to end up with 15x squared minus 20x minus 6. And that's going to be over our 5x minus 2 and our 2x plus 5. So I went ahead and multiplied these. That would be negative 90x squared. And I started dividing by numbers. So I could find no factors of negative 90 that when added together give you a negative 20. Now you could also do this with the quadratic formula and find out that you end up with an irrational number underneath the radical, which tells me that I can't factor it out anymore. So ultimately then when I write my answer, I'm just going to leave what I have on top, 15x squared minus 20x minus 6, and then I'm going to multiply, again, the two binomials by each other on the bottom. And when I do that, I get 10x squared. Multiply the outside, that's 25, minus 4, that's 21, so that's going to be plus 21x. And then negative 2 times positive 5 would be minus 10. So that's our answer right there, guys. We cannot simplify this one anymore. Now, the x values that would be excluded would be 5x minus 2 equals 0. So 5x equals 2. Divide both sides by 5. So that would be x cannot equal 2/5. And then we would do 2x plus 5 equals 0. So we get 2x equals negative 5. Divide both sides by 2. So x can also not equal negative 5 over 2. So those are the undefined values for this problem.